welcome to this topical meeting. First note of business, last Saturday was supposed to be our opening star party, get together, get to know each other, but Tucson had other plans, so we watched Wall-E and we played games, and it was fun anyway, so it was cool. Just noting that. So to follow that, we have another movie night this Friday, which is going to be a regular thing. It's the bad sci-fi movie night, so you just come here and watch a bad sci-fi movie and socialize and not do homework. That's this Friday. Hopefully that room's going to stay the same in 505. We'll watch the core of this month. Next piece of news. I've been talking about this for a couple weeks, but it's starting to come up. Not this Friday, but next Friday, we're doing 61-inch eyepiece observing, and I recently learned that there'll be free pizza, and there'll be a chance to socialize with grad students who will also be there.
How many people are interested in coming?
I have a sign-up sheet.
Okay, sign-up sheet. There we go.
Everybody that wants to go, hopefully, if you are able to go, this is like a final say because we have to give a list to people because we're getting pizza and stuff from a graduate student fund. We have to know how many undergraduates are going, just for logistics. And so we have a sign-up sheet, so put your name down, and also put if you can drive and the number of people that you can drive, including yourself, if you're going.
Guess all the telescope operators will want to go to that.
Yeah.
John Fleming wants us to operate.
Oh,
so I guess I can't go.
Okay.
Well, we're not going to start observing at the 61 until like 11 o'clock.
Oh, okay.
Yeah.
That might work then.
Yeah.
All right.
So-
Because there's a class usually the 61 is before us. So all of us basically go to the top of Mount Lemon, we'll socialize, have pizza, watch the movie, goof around, and then head down to Bigelow once that class is gone. Okay, so that's the next one.
So lots of fun, and then at 11 o'clock we go to the mountain. That's pretty much all the events we have immediately coming up. After the 23rd, there's the 30th, and then October 7th is our October 8th, or actually never mind, October 1st, if these numbers are right, is our next Sabino Canyon Star Party. So just get that in your head, and we'll have that then. Next, membership. I know a lot of you have already signed up and have paid dues, but just a reminder, if you haven't paid dues, they're $10 a semester, and we have Kevin and Blythe here to take your money so we can use it for club funds and pizza and stuff like that. We have a few projects going on. Exoplanet project started 2 days ago. It's 5:30. We made it the south entrance. You can still, even if you missed last week's meeting, you could still tag on, and it's a good experience. Binocular telescope meeting. I know last week I put 4:30 for this time. That was incorrect. I apologize. The meetings are at Tuesday at 5:30, and also outreach materials. Talk to Katie, and that's going to become important because we're going to start. One of the things we do throughout the semester is we go to Biosphere 2, and they have Science Saturdays events, and we go there and just do outreach for all the people at Biosphere 2, and you get a free tour of the Biosphere, and we use like the materials that we've made, like our star model, and we have all kinds of other things that we just research, like we did impact craters once, and other stuff like that. So these outreach materials are going to become useful when we go there and do that.
Just a show of hands, who all is interested in going to the BIOS group for like Science Saturday type events, activities? Okay, those will probably start up in like the second half of October. I'll email them with a few dates that we have in mind. We'll probably do 2 or 3 events this semester. They're really excited. They really like when we come, and everybody who has gone there and when we're there have all had positive feedback. So they love us. So
Yeah.
more information will be coming.
So yeah, that. And then also we have the radio project going on. We meet at Thursdays at 5:05 in 5:05. I didn't realize that until someone was like, "Was that the room number or the time that you put in the email?" I'm like, "Yes, actually." So, and there's still an opportunity to get into that if you didn't make it to last week's meeting.
Speaking of which, anybody on the radio project, stay after the meeting. We have things to discuss really quickly.
Also, one thing, we were contacted by people at Flandreau interested if we were interested in writing for this Skywatcher's Guide. I'm not sure exactly.
Yeah, so the folks over at Flandreau, last year their basically lead astronomy person took a position on KIPI, and he's now doing that full time. So he's no longer keeping up with the Skywatcher's Guide, and a lot of people actually look at this. It's just a page showing what's up in the night sky, and they were asking if we were interested in kind of taking over the Skywatcher's Guide. Basically, we could write almost whatever we want about what's going to be up in the sky for starting in October. It's a monthly thing, so once a month. A good idea might be to just sit down and do like 6 months in advance and just be done with it for a little while. But I guess their question to us is there interest in sort of putting this together? Would anybody want to join in on helping compile that? Or is it something that we don't want to do? So if there's interest, raise your hand. A couple people. Okay. We might put together a committee. October's coming up pretty quickly. Also, this would get us really good exposure, since a lot of people do visit this website and it gets a lot of positive feedback. We would definitely be prominently displayed as a club on this site. So come talk. Yeah, definitely. And we can probably just put an advertisement for Sabino Canyon directly on the website. So that would be really good exposure, and we can get our name out there a lot more if we take this over. Come talk to me right after the meeting if you can.
Finally, I mentioned this before. If you want to talk about your research, this is a good place to start. So if you did research over the summer or last year or 10 years ago and you want to talk about it, come talk to me after the meeting and I can hook you up. Because otherwise, this is 10 minutes in and I'm pretty much done with everything I need to talk about. But it's just great to hear undergrad research is a really good.
And just give you stuff you're starting to review.
Yeah. Oh yeah.
Like, just trying to put some background together and say this is the way.
Yeah.
So everybody knows how you
Yeah.
started.
And speaking of which, today we have Carmen Austin, who I remember is talking about what she did over the summer, learning about action script.
So, I don't know if you guys want to go ahead and talk about
Okay, just go ahead.
Okay. So what I did was not related to astronomy. As a first one, but it was cool. Yeah, I worked in the Department of Speech, Hearing, and Language Communication here called the Festival of and I worked for documentary alt. And yeah, I came up with this kind of long title for which I would have did action script programming for game-based evaluation using our word memory. So the next slide, hope I can explain because get it right away what that means. So it's important that you understand what working memory is. Working memory is kind of like what you might think of as short-term memory. It's just the temporary, how your brain temporarily storing and manipulating information. And you need to have good working memory so that you can learn things, memorize things, and that kind of thing. And there are different people have different ways of looking at working memory. There are these 4 different models of it. And so the most complex model has these 4 components. So these 4 things here are components of working memory, not the 4 different models. But the most simple model of working memory just has this one component, the central executive. And that's your attention controlling system, so it's how you're deciding what you're focusing on at the moment. The next least complex has just these 2, central executive and phonological loop, and et cetera, et cetera. So phonological loop is kind of like the voice in your head, I guess, like you're memorizing or remembering sounds. And if you use spatial sketchpad, you look your mind's eye, remembering visual things. And the episodic buffer is just what is tying everything together. So it's just important that you understand what working memory is, so that I can talk about what I did. The project that I'm working on, or that I am still working on actually, but that I worked on over the summer, the main hypothesis is that word learning success depends on the contribution and interaction of all those 4 components, or however many components that are in the model, the particular model that you're using, so all 4 or the first 2 or whatever. And word learning variability is related to a child's working memory profile. So your ability to learn words is related to how your working memory works. And if your working memory doesn't work the same way as another child, you're going to need to learn words differently. So why do we care? Well, it's really important because people need to be able to learn words. You learn words mostly when you're young. So we need people to learn words, and if you're not learning words well, you need to understand why you're not learning words well, and you need to have an effective way of helping you. So to test the hypothesis, we compare things. So we have our models of working memory, and so we have to make models off of actual children with data from actual children and compare them and see what we can learn about like which model or which components are most important and that kind of thing. Anyway, we are going to test 5 different groups of children. These top 2 groups are just children with tuple development. So it's monolingual English speakers and bilingual speakers who speak Spanish and English. And they both need to exhibit tuple development, so they can't have like vision problems or hearing problems or anything like that. And then these 3 groups do have impairments, but they're specific kinds of impairments. So the first one is specific language impairment, and the next one is dyslexia. And then finally we have a group of children who have both specific language impairment and dyslexia. And so, you probably definitely already know about dyslexia, because everyone's heard a lot about that. It's when children who have difficulty reading or comprehending what they're reading or have trouble spelling, and all these problems are not caused by impaired vision or they weren't taught correctly or anything like that. Then SLI, or specific language impairment, is sort of kind of the same thing, except for instead of reading, it's with your speaking. So they don't start speaking as early as other children who speech and that kind of thing. And again, it's not caused by being lost or autism or anything like that. So the long-term goal of the project is to help kids who aren't learning very well, who don't learn words the same way that maybe a typical developing child would. So you can go to that. So you're probably wondering, what on earth was I doing working on this? Is like not astronomy at all. Well, when I got the lab, I got to be working there because I did an RU through the physics department. So I don't really know why this lab was in the mix, but it was. So what I offered to do for this project, or as my job in the summer, was in programming because, like I said, what did I say? The way they're gauging these kids and getting their data is they have computer games. Because with kids, when you're doing like a study with people, you can't really do it like with adults where you just go in there and, I don't know, have a survey or just talking to them. Like you have to keep their attention and it has to be interesting or like they want to know what you're supposed to do. So they use computer games, so that's how they do it. So they have to have someone programming these games and be very specially designed. So that's what I offered to do. And I figured that was kind of related to astronomy. You know, programming and be able to do that kind of thing. That's what I offered to do. We use Flash, Adobe Flash to make the game. So I programmed in ActionScript 3.0, it's the language that you use when you make something Flash. So this is what Flash looks like. You've never seen Adobe Flash before. You've probably seen like Photoshop or InDesign. This is what Flash looks like. And so this is what probably most people look at and see when they develop Flash games. You've got like your picture, and then like your whatnot. And you have the tools, like Photoshop. And then this is what it looks like when you're writing code to use in the video. And you also have your timeline over here. And then this window is also where like compiler errors and that kind of thing come out. So this is where you're programming. And you can see here we have in ActionScript, these things called trace statements. They're kind of comparable to like pipeline. You're right. But oh yeah, you can. So we have trace and then whatever, and then it picks it out from the output. So okay. So that one screen before, that was what I was looking at. Yeah, this is what I was looking at. A little bit of that side, most of this side is black. So yeah, next. So this presentation I made with, when I made this for when I presented at the end of the summer to everyone in the RU program what I did in my lab. We were all in different labs. And I had a game prepared for them to play. And I don't think that's the case today because I didn't think to send it in. And I don't even know if it's right. He asked me last night. So it's not ready. But one of the games, actually 3 of the games that I helped make or that we're making for this project are the Stroop games. So have you all seen like these posters or images on the internet with like all these different words and the names of colors, but they're in different colors, but they're not necessarily like the same color that corresponds to the actual word. So like the word green, that's blue, that's the Stroop thing. That's what they call that in that science. So I guess there's this guy named Stroop who first ever studied the effect of how obviously it's easier to read words if they're color words. The color of the word is the same as the word. And anyway, we made these 3 games for this. First of all, we have just the baseline game. So all that does is it shows you a word, like a black word, and you have to be able to read it. Read it correctly and whatever and all that. And then it shows you just asterisks on the screen, and the asterisks are in different colors. And you have to say the color. And then you will be listening and you'll hear the word, and you just have to repeat the word. So that game's probably kind of boring, not very interesting. It's just repeating or whatever. But then, it starts to mix it up. So we have, that's the Stroop baseline, and then we have Stroop Classic, where they see a word on the screen, and the word is a colored word. It might be green or red or blue or yellow. And then the word itself is either the word red, blue, green, or yellow. They might correspond, they cover them down. So you're asked, you play it twice, and the first time you're asked to just read the word and ignore whatever color it is. The second time you're asked to say the color and not read the word. And then finally, there's Stroop cross-modal. So in Stroop cross-modal, you see the asterisk, the colored asterisk on the screen, and you hear a word in your head. And you play it twice again, and you're asked to either repeat the word that you hear and ignore the color that you see, or say the color that you see and ignore what you see. So those are the three games. On the next slide, I don't exactly remember. Okay, yeah. This is the diagram. This is what the screen looks like. Well, except it doesn't have all four at once. It'll have like just the yellow in the center. And then it'll say blue, and you have to either repeat or whatever. So this is what the actual game looks like. So it's kind of complicated because this game is actually listening to your voice, like you have a microphone. And we've had some trouble with it because the guy who did most of the programming did it on his computer with his microphone and it worked well. And then when we use it with our microphone on our computer in the lab, it doesn't really work as well with some other stuff. It's weird. But what's supposed to happen is this bar across the top, and I don't know how well you can see it, but there's a green line there, and there's a red line there, and then there's this blue thing. The blue thing moves, and it is supposed to hover around the red bar, like when no one's speaking, and then when you say something, it should hear you, and it should kind of like jump up and go past the green. So when it goes past the green, that's when it knows you've spoken, and it changes what's on the screen. At least that's what's supposed to happen. And it does work well on some computers and not on others, so that's just an issue that we're working with and we'll have to sort out. In the end, when we actually play the game with kids, we'll be using the same computers all the time, so really as long as it works on those computers, it should be fine. But yeah, those are the three different games. You can tell me to work. Let's see what the next slide is. Oh, it says, let's play the game, which I don't have, so we'll go on. So, if you haven't quite got it already, we have all these different games too, like tons. So the theme of the game is like pirates. You have this pirate that goes through all the games to you. And if I had a game prepared to play, then you would see the like narrator pirate who's talking to you before you play the game, telling you the instructions and whatnot. But all the games are kind of like piratey themed, but there's like this world of islands, right? So there's like Sea Monster Island and Animal Island and Candy Island and Robot and all these different islands. And so all the games on a particular island are not only pirate and islandy themed, but also like robot themed or toy themed or whatever. So the street games, well, they're on 3 different islands, but for instance, I don't remember how they relate to the island they're on. I don't know, but another game I worked on was called Stop Signal Interdiction, and it was basically it was on Candy Island. And so you're on Candy Island, and the sea monsters are invading Candy Island, and so you have to stop the sea monsters from getting the candy if they catch them in the net. So when you see a sea monster, you have to hit the space bar, unless the monster is actually the pirate narrator guy's head, in which case he blows his horn. So you're supposed to be hitting the space bar, but you have to stop yourself if you hear the horn. So that's just an example of another one of the games that I would know. But yeah, all the games are pirate themed, and all the games, their purpose, the kids play them, we record their accuracy and their response time or whatever else we need. Typically it's just accuracy and response time, and that's our data. And all the games, all the tasks, how there are different tasks that we need to, and when we get the accuracy and response time, it gives us an idea of the different components in the memory. So when we get an idea, when we get the data, we get their accuracy and response time for the different games, I think that should give us an idea of how that specific child's working memory operates. And then we have the 5 different groups, so we can have a group of students for, each different scenario, and we have an idea of what, hopefully we get an idea of what working memory looks like for typical developing monolingual English speakers, and then kids with dyslexia, and we can compare that. And then, I think that's about it. This is just what the output, we have to have an output tolerance, so every time you run the game, it makes a file that records all this stuff. And the most important thing is the response time, which is in milliseconds, and their accuracy, whether they got it right or wrong. And then this other stuff is mainly just to verify. So this is for a game I worked on called End Back. And you saw these cards flashing on the screen, and you had to decide whether or not the last two cards you saw were the same. So, like here we have card 5 is the previous card, and the card you just saw is card 5. So they're the same, so you should have hit the green button and not the red button. But next, you see card 2, so the previous card is card 5, right? And then you see card 2, so they're not the same, so you have to hit the red button, not the green button. That's just what an output file is like. And this is how you write this form. So kids with dyslexia and SLI are going to do pretty bad in everything. And the monolingual English speakers are just going to be kind of normal, average. So that's all that means. That's what I do with this one.
Any questions?
Yeah.
So I guess that's.
Oh, I almost forgot. I actually have. I was just asked, literally like right before I came by my boss, would I recommend it? If there's anyone here who wants to volunteer on the night of October 8th to work up on the mountain, there's a event, family night. It's for the people of the Nation and stuff. So we need someone, just like 4 people, I think. People who actually know the mountain properly. And by that, it's a Saturday.
Yes.
October 8th. Yeah, I thought you would make it with that. So anyone else who, and I don't mean like know every class culture, but like the social culture, and you can make some problems with it. I think that's all those are right. Please let me know if you're
It's possible if you're really interested in people learn all that.
It is possible. It is possible, especially if you have a little bit of an idea. But I don't know. Although she's not really in charge of the event, so yeah, just.
I guess I kind of brought up one question I had. Like, could you explain how you got this research?
How I got it?
Yeah, how you got it.
What did you do to end up with this?
Well, I actually, for the long version, I was taking a physics class at Homer, and my teacher asked me if I was interested in applying. I was like, oh yeah. And so I applied for an REU with the UA physics department. Okay, and how it works is they have there were 14 of us who applied and worked on this program, and then they had 12 different labs. And so for the first couple of weeks, we went on tours of the labs and kind of picked which ones we wanted. And this was not my first choice actually, but it was fine. So we kind of all picked, and they placed us in best they could. Most of the labs were actually related to BBC things or engineering things. It was really rare, but it was cool. And I get to keep working there, which is nice. I haven't worked out, but the programming, I learned so much. It was crazy. But yeah, the way that REU worked was they had 12 different labs, and they had 14 students, and they tried to match us up with these different labs. And I'm trying to think of examples of other labs. There was one you could work for Roger Angel here, and there was one in the chemistry department. There's one at Bio 5. They're kind of all over. There are a couple in the physics building too at the So, yeah.
And for those uninitiated, she said REU is research experience for undergraduates, and there are these internships that happen all across the nation over the summer. So towards like when it gets closer to winter time, that's when you start applying for RAUs and you get research jobs over the summer where you get paid about ish.
Yeah, and you can find them all online.
Yes.
Like if you Google
And they're in all fields.
Yeah.
There's, Amy worked for NRAO, I worked at Flagstaff on the whole, and they have them all over the country. Here at Seago,
Yeah. Lido a couple years ago.
NSF has a pretty good list.
Yes.
Yeah.
Just Google.
So yeah, let me know about date.
So that's it. I will see you